of transcription. And so we're going to write them down in groups of 3, because remember, 3 nucleotides equals a codon. Codon is a set of 3 nucleotides okay, so we have AUG, and then GGU, and then GCA, and then AGU, and then AUA, CAC, and then UAA. So this is going to be our strand of messenger RNA. And so when we first started out talking about RNA, I said that messenger RNA, I'm either going to draw as a line or a squiggle. Transfer RNA is going to look like a U with a bead. And then ribosomal RNA is just going to be a blob. And if you remember, we talked about how the ribosomal RNA, if we're talking about the ribosome, it's a complex of proteins and ribosomal RNA. And so it's very complex. We're going to simplify it to this crazy blob right here. Okay? So AUG is actually a special codon in that it is a start codon. And so it kind of gives a starting point for translation to start. And so the ribosomal RNA, or the ribosome, is going to be attached to the RNA in that location. And the first transfer RNA is going to come in and sit down in the first location, and it's going to bring an amino acid. And so the B that we've been talking about on our transfer RNA is the amino acid. Another part of the transfer RNA we got to talk about is the codons that are going to match the messenger RNA. Remember, there's no thymine in RNA, and transfer RNA won't have any thymine. This set on the transfer RNA that matches the codons on the messenger RNA is called the anticodon. So it's the opposite of the codon. And so each transfer RNA is like a taxicab, and that taxicab can only pick up specific amino acids. And so this transfer RNA with the anticodon UAC is only going to pick up the amino acid methionine. And we're just going to put the first 3 letters of the amino acid, which is MET. So the anticodon UAC is only going to pick up the amino acid MET, methionine. Okay? The next thing that happens is that the chain is going to scoot over. So it's going to move over on the ribosome. The next transfer RNA is going to come in. And it's going to bring the next amino acid. The anticodon CCA is going to bring the amino acid glycine, so GLY. So now we have 2 amino acids together, and something special is going to happen. Sorry, you guys can't erase, but I can. A bond is going to form between the 2 amino acids, and this bond is called a peptide bond. So the bond between amino acids is a peptide bond. So the chain is going to scoot over again. So we have our ribosome moving, or you can think of the RNA moving. The first transfer RNA has dropped off its passenger or its amino acid. So methionine is bonded to the glycine with the peptide bond. So the first transfer RNA is going to leave, and it's going to go back into the cytoplasm and find another methionine to pick up. The next transfer RNA comes in, and I do that one a little too big. And so the anticodon, and I messed up there, not enough space. Make this smaller. The next anticodon comes in, and it's going to be CGU. And that anticodon is going to bring in the amino acid alanine, ALA. A peptide bond is going to form between the glycine and the alanine. And our second transfer RNA has dropped off its passenger glycine because now it's bonded to alanine, and it's going to go back out into the cytoplasm to find another glycine. We scoot down the chain again. The next transfer RNA comes in. It's going to have the anticodon UCA. It carries the amino acid serine, so SER. A peptide bond is going to occur between the alanine and the serine. The old transfer RNA is going to leave. It's going to go back into the cytoplasm and pick up an alanine because it's dropped off alanine. Chain is going to move over. We're going to get the next transfer RNA that comes in with the anticodon UAU. And it's going to carry the amino acid isoleucine, so ISO. Peptide bond happens between serine and isoleucine. The transfer RNA with the anticodon UCA has dropped off serine, so now it's going to leave and go pick up another serine in case it's needed. Our chain scoots over. The next transfer RNA comes in with the anticodon GUG. It's going to carry the amino acid histidine, HIS. A peptide bond occurs between the isoleucine and the histidine. The transfer RNA has dropped off the isoleucine, and so it's going to break off and go back into the cytoplasm to pick up another isoleucine. Our ribosomal complex is going to move over again, and this time it hits another special codon called a stop codon. And there'll be like 3 main stop codons that you'll see when we get to using our codon charts. So when we reach the stop codon, the last transfer RNA is going to break away and go pick up another amino acid. And so we end up with the RNA complex where we have the ribosomal RNA with the messenger RNA, and if we need more than one protein, it's going to go through the process again. But we end up with a chain of amino acids. So we have meth with a peptide bond to glycine, peptide bond to alanine, serine, isoleucine, and histidine. And so in our example, we don't have very many amino acids, but proteins are made up of thousands of amino acids, and they're quite complex. And we're not quite to a protein yet. What we have made is what's called a polypeptide chain. Poly means many, peptide, the peptide bonds. So it's not quite a protein yet. So what happens is it starts out as this long strand, and then it starts to fold in on itself. And as it starts to fold, we get hydrogen bonds that are going to form between that twisting area, and that's going to help stabilize the protein shape. So it's going to fold and keep folding and folding in upon itself, and then we're going to get a very specific 3D shape for our protein. I'm sorry, I can't draw 3D very well. And so that's going to determine what the protein is and what its function is going to be. And if you remember, yesterday we talked about how proteins are different in their 3D shape. So the end result of translation is reading the code in messenger RNA